Good morning. Myself, Dr. Maheshwara Rao, Department of Civil Engineering, Institute of Aeronautical Engineering. So our course name is Fluid Mechanics. The topic is measurement of pressure using various mechanical gauges. Here, measurement of pressure. So why should we learn this pressure measurement? So if you don't measure this, then there may be chances of failure of pipes and any devices. So that if you know the pressure, then only we can design the pipes, the pipe thickness, devices, etc. So that's why we have to know the pressure initially, so that we can design the things. And also after designing, also after execution, also we have to check the pressure inside that particular pipe. What is the pressure, existing pressure? So if it is beyond the limits of that pipe pressure, then we have to reduce the pressure. So that's why here the measurement of pressures, the pressure can be measured. The pressure can be measured by using the various mechanical gauges. So here are the course outcomes, that is, students will be able to learn after completion of the topics. So here, course outcome 1. So it is the definition of the fluid and its properties and surface tension and different conditions. So that will come under course outcome 1. So then Newton's law of viscosity and fluids classification and problems, some of the problems related to the Newton's law of viscosity. So that will come under the course outcome 2. And course outcome 3 is the capillary rise or fall. So what is the capillary rise and fall means? A small diameter pipe, if we insert in a fluid, the level of that fluid will rise compared to the top surface of that particular fluid, which is called capillary rise. Or some fluids, if you insert a small diameter of tube in the fluid, the surface, the level inside the small diameter pipe will fall compared to the surface of the fluid. Then it is called capillary fall. So that will come under course outcome 3. So course outcome 4 is the concept of surface tension. Surface tension means any fluid will have tension at the top surface of the fluid. So that relates to course outcome 4. And capillarity and compressibility will come under the course outcome 5. So what is this compressibility? So if you take the liquids and gases, the liquids we cannot compress it, whereas the flow of gases we can compress. That means we can make the change in volume of that particular fluid. So which is called the compressibility. And course outcome 6 is the pipe flow. So what is the pipe flow means? Any fluid, if you allow to flow through the pipe, that is called a pipe flow. So what will happen there? Friction will be there. So the surface of the internal surface of the pipe material and the surface of the particular fluid will have a friction there, so which is called fluid friction. And while it is traveling from one point to another point, it loses its energy. So it may be pressure, it may be datum head, or it may be, it will be lost. So this pipe flow and fluid friction will come under the course outcome 6. So, and today's topic is measurement of pressure. So how the pressure is measured using the mechanical gauges. What is the meaning of pressure? Pressure is nothing but the force by area. So the amount of force divided by the unit area, which will be called as the pressure. So we have to measure the pressure of the fluid, which is inside a pipe or inside some point, at any point in the fluid. That is called a pressure. So how to measure pressure at that particular point? So how can we measure means by means of the mechanical gauges. So some equipments are there, mechanical gauges, which are called mechanical gauges, so that we can gauge the pressure or we can measure the pressure. So if you see this introduction to pressure measurement. So the pressure measurement is a fundamental aspect of fluid mechanics. So very, very important thing in the fluid mechanics is the pressure measurement. So it is very, very important. So otherwise we cannot design, or even after execution also the failure will take place if it exceeds the designed pressure. Okay. So it is essential for understanding the behavior of fluids in various engineering applications. So that's why we have to know the concept of the pressure measurement. So the pressure gauges are instruments. So pressure gauges means nothing but the instruments or equipments, okay, to measure the force exerted by the fluid per unit area. So how much force is exerted by the fluid? So if you take it is a pipe. If it is a pipe, so inside fluid is there. So it will exert some pressure onto the surface of the internal surface of the pipe material. So the force exerted by the fluid material on particular unit area, okay, unit area. So that means per millimeter square, or per centimeter square, or per meter square, like that. A force, how much force is applied per unit area, that is called a pressure here. Okay. So accurate measurement is crucial. Here is accuracy. So we should measure the pressure accurately. So why should we measure? Weight is very, very important, because if we want to design, so if you want to design a pipe or machines or equipments related to that pressure, so you should measure accurately the pressure. Okay. So controlling, monitoring. So if you want to control the fluid pressure also. So because if it exceeds the maximum pressure of that particular equipment or pipe, it will burst. It will fail. So that's why we have to control it by removing some pressure. So if it is exceeding the pressure inside of that particular equipment, so we will reduce the pressure by removing the pressure there. And monitoring the fluid system, such as water distribution works. So what is the water distribution works means? So from the overhead tank or tank to water will be supplied to the domestic houses by means of the pipes. Okay. So we have to monitor the pipe materials, pipes. So you have to reduce the pressure in case of the excessive pressure exists in the flow of one. So here, water distribution networks. Networks means it is nothing but the connection of the pipes which is passing to different houses. Okay. So if it is overhead tank, let us take. So here pipe will come here, so it will travel. So then it goes some like this. So here some house will be there, and here some other house will be there. So like this network of pipes, network of water pipes or fluid pipes, that is called a water distribution networks. So if you want to maintain properly, if you want to monitor it, if you want to control it, so you have to measure the pressure inside that particular pipe. So otherwise, if in case of low pressure also, what will happen? The water will not reach to the very farthest house. So there, the house people will not get water because of the very low pressure. As it is traveling from this point a long distance, all the energy will be lost. So that if energy becomes zero, then last house may not get the water. So not only to see the safety of the pipe material, but also to see the availability of water for the domestic purpose. So that's why pressure measurement is very, very important. So if the high pressure, how much pressure should be here in order to reach the water at the last house. So that we have to measure the proper pressure so that last house will get water. Okay. and hydraulic systems and pneumatic devices. So all these will require the checking of the pressure inside of the particular devices. Otherwise, the device may failure. So if you see there are so many types of mechanical pressure gauges. Mechanical pressure gauges. That means it is nothing but a device. The pressure gauge is nothing but a device, so that we can measure the pressure of inside a pipe or any device. So those mechanical pressure gauges. See here, the mechanical pressure gauges are widely used due to their, why it is used. Mechanical pressure gauges means it is simplicity. So they are very easy, simple, reliable, and ease of use. So why should we are using the mechanical pressure gauges? Because of its simplicity. It's a very simple one. Very easily you can get that, and reliability. So very accurately will get the pressure measurement, and also ease of use. So everyone can use that easily. So that's why mechanical pressure gauges are used. So the primary types of mechanical pressure gauges are. So what are the primary types of mechanical pressure gauges are? One is Bourdon tube gauge. So here Bourdon tube gauge is nothing but the C-type tube. It is a C-type tube. So what will happen if you apply a pressure, you send any fluid here inside. So because of the fluid pressure, this C curve will rise to in straight portion. It will get straight portion because of the pressure. See, as pressure increases, okay, so it instead of the C type, it is getting straight line portion. So depending upon that movement, it will be attached to the point so that we can measure the pressure. That means pressure inside that particular pipe material. That is a Bourdon tube gauge. So we'll see the construction and how it is working in the following slide. So you can see this. This is a needle, so that this is structure C type. Okay. So whenever we are allowing a connected to the pressure pipe, so that the fluid will travel through this, so that because of this, it tries to elongate here. It will become like this, so that this mechanism will rotate like this, so that the pressure needle will move in this direction, so that we can measure the pressure. Okay. See here, the Bourdon tube is a curved, so it is nothing but a curved, hollow tube. Initially, it is a hollow one. So it is made of metal. So what is the material used for this tube? It is a curved tube, is a metal one. So normally it is a C-shaped or spiral form. So there may be two shapes for this Bourdon tube gauge. One is C-shape, or another one is spiral one. Okay, spiral form. So when fluid pressure is applied, the tube tends to straighten. So whenever a fluid, if you connect to the whenever pressure is increasing, so that will tries to straighten. The C-shape or spiral shape will be converted in, will turn into straighten due to the internal pressure. So this movement is transferred to a pointer mechanism, indicates the pressure on a dial. So this is a pointer, so that because of the straightening of this C tube or spiral one, so it moves like this. So gear system will be there, so that this needle will move this like this. So in this direction, so that we can measure easily the pressure, internal fluid pressure, which is a Bourdon tube gauge. And applications. So where we will utilize this Bourdon tube? So BOU or DOL, Bourdon tube gauge. So here it is industrial purpose it is used. So it is Bourdon tube pressure gauge is used for the industrial purpose. So it may be used for gases as well as the liquids. So it works with the, you can measure the gases, pressures of gases or pressures of liquids also. For both the fluids, this Bourdon tube can be utilized. Okay. So where it will be ranging? What is the range of this device? So from vacuum. So from vacuum to several thousands of PSI. So from vacuum to thousands of psi you can measure. That is the range of this Bourdon tube pressure gauge. Another one is the diaphragm pressure gauge. Diaphragm pressure gauge. This is the figure of the diaphragm pressure gauge. Okay. So here what is there? Here it is a diaphragm. So diaphragm will be there. Uses a thin flexible membrane. Diaphragm means what? Very thin flexible membrane. Membrane means a sheet. Okay. Flexible sheet. Flexible means it is not stiff. Okay. Flexible membrane or diaphragm that deflects in response to the pressure. So this thin sheet or a diaphragm, flexible membrane, the diaphragm will bend or deflect. Deflect means what? See, if you apply force, example like this will bend like this. This is called deflection. So here also, because of the application of the pressure, the diaphragm, that means a thin membrane, flexible membrane will deflect depending upon the pressure, existing pressure. So in response to the pressure, it deflects. So the deflection is transmitted to a pointer through a mechanical linkage. So the deflection is connected to the pointer so that the pointer will show the pressure existing in that fluid. So diaphragm pressure gauge applications, where it is used. Bourdon pressure is used. Bourdon pressure is a tube, C-type tube, okay, and used for industrial purpose. The range is vacuum to thousands of psi it can measure. Similarly, this membrane, okay, diaphragm gauge. So it is nothing but a very membrane, that means very thin sheet, flexible sheet. So it will respond to the pressure. So in response to the pressure, the needle will move, so it can measure the pressure. Okay, where it will be ideal. So it is ideal for low pressures. So whereas Bourdon is vacuum to thousands of psi, but it is not for the higher pressures. It is for lower pressures. So diaphragm pressure gauge will be used for the low pressures. So, okay, or for corrosive fluids, or also for corrosive fluids when the diaphragm provides a barrier between the fluid and the measuring mechanism. Okay, so that is the application of that diaphragm pressure gauge. So it is used for the low pressures. So another type of mechanical pressure gauge is the capsule pressure gauge. So you can see the figure here. This is a capsule pressure gauge. So you see the construction and working. So what is there here? It consists of capsule. Okay, it is a capsule made of two corrugated diaphragms. So in the diaphragm pressure gauge, only one diaphragm is there. That means small membrane, very thin membrane. So which deflects depending upon the application of the pressure. So here is the two diaphragms are there. In the diaphragm pressure gauge, only a single diaphragm is there. In the capsule pressure gauge, two diaphragms are there. And also these diaphragms are having corrugated. What is the meaning of corrugated? So like this. So strike membrane is the diaphragm pressure gauge, and this capsule pressure gauge is having corrugations. Okay, this is a corrugated thin sheet, and these two corrugated diaphragms shouldered together. They will be shouldered, joined. Shoulder means they are attached, welded otherwise. Okay, the capsule expands or contracts based on the pressure applied. So the capsule will expand or contract depending upon the pressure here, depending on the existing pressure. So this movement, contracts and expansion of this capsule will drive a pointer so that you will get the pressure of that particular fluid. Okay, this is also used for the low pressure measurement in gases. So it is used for the low pressure measurement in the gases. Till now we discussed the Bourdon pressure gauge. Bourdon pressure gauge, it is a C-type hollow tube, and it responds as the pressure increases. The C-type will turn into straight. So that can be used for the vacuum pressures to thousands of psi. So for both the gases and fluids. Whereas this diaphragm pressure gauge is a small membrane, thin sheet which responds, deflects due to the pressure of the fluid. So the application is that for low pressures, it will be utilized. Whereas this capsule pressure gauge is also diaphragm, that means small thin sheet, but it is a corrugated, and also two corrugated membranes. Okay, so these two corrugated diaphragms are attached to each other. Okay, so that means it is soldered. So depending upon the pressure application, there will be expansion or contraction of this capsule. Okay, so it is used for the low pressures of the gases. So if you review today's one, so here if you see the pressure measuring mechanical gauges, the introduction is that it is very, very important to measure the pressure in the fluid. That is very important one in the fluid mechanics. So in order to understand how the various equipments can design all those things. Okay, so to measure the pressure is nothing but the force exerted by a fluid per unit area. Force exerted by a fluid per unit area, that is called a pressure. So the equipment used to measure that pressure is called pressure gauge. So pressure gauge is nothing but the equipment or device utilized to measure the pressure of the fluid. Okay, so here it is a accurate measurement is required in order to design the particular equipment or a device or a pipe. Okay, and also not only for designing, for controlling and for monitoring the water distribution networks. That means the combination of several pipes from the tank to the houses, domestic houses, and also hydraulic systems, pneumatic devices. So all these things, it is designed, monitored depending upon the pressure. Okay, that's why accurate measurement is very, very important, so that we can measure with the mechanical gauge, we can get the accurate pressure measurement. So if you see the different types of pressure gauges, number one, primary types of mechanical gauges are board-on type pressure gauge. Here it will be in a C-shaped tube, hollow tube, and whenever a pressure is rising, so it is leading to the straightening this one, so that it will be attached to a pointer, so that you can measure the pressure inside the particular fluid. So you can see this figure. So here board-on pressure is a curved hollow tube which is made of metal. Okay, shape is C-shape or spiral form. So when a pressure is applied, it tends to straighten. So this is a C-shape. So it will be straightened like this. So that mechanism is there attached to the pointer, so that the pointer will give the pressure of that particular fluid. So the movement is transferred to a pointer mechanism which indicates the pressure in a dial. This is called a dial gauge. So application where it is used in the industrial purpose for the gases as well as the liquids. So we can measure the pressures inside the liquids, or we can measure the pressure inside the gases also. We can utilize this board-on pressure tube. So the range of this particular board-on pressure gauge is from vacuum, also it can measure, and to several thousands of high pressures also, PSI also we can measure. Board-on tube pressure gauge. So similarly, diaphragm pressure gauge. So diaphragm pressure figure is this one. So here diaphragm is there. That means a thin flexible sheet or membrane. It will deflect. So if you apply a pressure, the thin membrane or sheet will deflect. Okay, so that it is attached to this pointer. So the deflection is transmitted to the movement of that particular pointer, so that we can measure the pressure of the particular fluid. So if you see the application, this is applied for the low pressures of corrosive fluids. Okay, so in a Bourdon tube, we can measure high pressures also, but here it is diaphragm pressure gauge is for the low pressures. And next mechanical gauge is the capsule pressure gauge. So it is nothing but two corrugated diaphragm sheets. That means thin sheets, but it is a corrugated in nature. So corrugated thin sheets, that is called corrugated diaphragms, soldered together, two corrugated diaphragms soldered together. So it will respond, either expands or contracts depending upon the existing pressure of the fluid. Okay. This also can be utilized for the low pressures, but in case of gases only, it will be utilized. The figure you can see the corrugations here. So this is the corrugations here also. The references. So Case Brumanu, Theory and Applications of Fluid Mechanics, Tata McGraw-Hill, 2012. And another reference is the Modi PN and SM Seth, Hydraulics and Fluid Mechanics, Standard Book House, 2002. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.